Hello, so today's lesson is linear function equations. So looking at the warm-up, just a review of equations versus the function notation. Okay, so the y is just replaced with f of x. All right, still the same concept. So what is the value of the function when x equals 4? So even if it was just equation form, you do the same thing. You plug in the value of 4 for x. So then you would have y is equal to 2 times 4 minus 3. So 2 times 4 is 8 minus 3, so y is 5 when x is 4. Same thing here when f of 4, 2 times 4 minus 3, you still get that 5. Okay, so quick review of functions. So is this relation a function? Absolutely not. Look at all those lines going to different numbers. Remember this line, this can only have one line per x. So this one's not a function. All right, on the multiple choice one there, let's look at our ordered pairs. So we have 0, 2, 4, -2, 5. That is a function. We're looking for one that's not a function. 0, 2, 4, 2. All right, so those 2's repeat. So it should be B. Just verify. -3, 2, 0, 1, 4, 5. -4, -3, -2, -1, 0, 1. So yes, so B is the correct answer. All right, so our essential question for this lesson, how do I interpret the slope and y-intercept in real-world linear situations? Today I'm writing and interpreting an equation to model a linear relationship so that I can use what I already know to figure out what some words mean. I'll know I got it if I can successfully model and interpret data in multiple representations. All right, so linear function. Okay, so here, this is the representation. You'll notice this is our y-intercept form. So f of x equals mx plus b. A linear function is a function whose graph is a straight line. Okay, important there, it's a straight line, linear straight line. Its equation can be written in the form of y equals mx plus b. There's our slope-intercept form, where x and y are used for independent and dependent variables, respectively. M cannot equal 0. Okay, so just some more information here. F of x equals mx plus b. Here's our slope-intercept form. F of x means the value of f at x. Okay, we just did that warm-up to show you that. Letters other than f, such as G and H or G and H, can also be used. So just so you know, that's more for when you get into algebra. Okay, so let's try this out. So we have a linear function can also be described using its graph. Let's determine the values of the function f if f of x is equal to 2x plus 1 at x equals -2, -1, 0, 1, and so on. So we have the first one is set up here. -2 times 2 is -4 plus 1 is -3. All right, we're not going to obviously have enough room to do all of these. So the next one you would just plug in, and I'll just put the work right here, the -1. You add 1, so 2 times -1 is -2, plus 1 is -1. All right, I can try to do the next one. 2 times 0 plus 1. This is 0 plus 1, which is 1. And then 1, 2 times 1 plus the 1. 2 times 1 is 2, plus 1 is 3. And our last one, 2 times 2 plus 1. 2 times 2 is 4, plus 1 is 5. And you should see a pattern in those. These went up by 1 each time. These are increasing by 2 each time. So there's our pattern. So linear graph functions can also be described using a graph. So we have the graph here, and then the ordered pairs are in the graph. So -2, -3 is right here, -1, 1, 0, 1, and so on. So this is already done actually. So it says let's determine the values of the function f if f of x equals 2x plus 1. And so it's just to demonstrate the graph. Okay, so once you have ordered pairs, you can plot those and make that. And remember, we can use the graphing calculator as well. You can put this in the table. And I may just do that real quick. Hopefully have time on this recording to do that. I think it's important that you understand how to do this. All right, so get to our calculator. So you have a table that you can click on right there, that plus sign. Hard to see the plus sign. Here we go, plus. Put the table. And so we have -2, -3, -1, -1. You really only need the 2 points. I already forgot -2, -3, and -1, -1. So there they are. You can click on this gear. Maybe it's this one. There we go. Sorry. So I just clicked and held on this to get where it says line. And you can put the rest of the points, and then you can see that it does form that linear line. So just remember the calculator. All right, next up, a linear function can also be illustrated using a table of values. We can do this by looking at the first difference at the x coordinates and the y coordinates. This should look familiar. I already talked about that when we did those values about 2 slides ago. Since both quantities change by constant amounts, this means the relationship between the quantities is linear, makes a straight line. Okay, we're going to focus on some real-world situations. So this graph shows temperatures starting at dawn, which is when the sun's coming up. 8 degrees is cold. That's why I put brr. Okay, is the function proportional? Okay, so proportional, nope, has to be here. So it has to start at 0, 0. So whatever time they started this, it's 8 degrees. So this is not proportional. So big no, circle Miss Horton there, no. All right, so what is the y-intercept here? It's just where it crosses the y-axis, so the y-intercept is 8. Okay, and if you wrote that as an ordered pair, it would be 0, 8. What does this represent? It's the temperature at dawn. Okay, because that's what the problem said. What is the slope? So rise up, run over. Well, it goes from 8 to 4, so that is plus 4. Oh, I'm going to change the color. If I can get that on the line there. So it goes over 4, because you got to watch your scale. So that's plus 4. And then it runs over, looks like 1, but look at the scale down here. This is 0, this is 4, so this is 2. So it actually is plus 2. So my slope is 4 over 2, which simplifies to 2. Oops, I ran out of room there. So my slope is 2. What does that represent? So this is time, this is the temperature. So the temperature increases 2 degrees every hour. Okay, because remember this would be like, you could have a 1 underneath that, so 2 degrees every hour. because it was 4 degrees in 2 hours. So it's 2 degrees each hour. All right, what is the equation? We're going to put it all together. We have our slope-intercept form. Slope is 2. Our y-intercept is 8. Write a function equation from a word problem. So we actually did this in Unit 2. So now we're just using this word function. So this, hopefully you remember how to do this. It says Dontina is ordering uniforms for her employees. The company is ordering from charges $18 per uniform and a shipping fee of $7. So this is per uniform and then a shipping fee of $7. So that's just an added on fee. Based on this information, write a function that can be used to represent the relationship between the total cost C and the number of uniforms Dontina orders in. All right, so our total cost is C. We don't know the number of uniforms, but we know they're $18 per uniform, so 18 times N. And then they have to pay this shipping fee of $7. So that's what that one would look like. All right, let's try this one. The cost of a school banquet is $95 plus $15 for each person attending. Write an equation that gives you total cost as a function of the number of people attending. What is the cost of 77 people? Ooh, a little extra there. Okay, so it's not $95 flat fee and 15 per person. So we would say y is equal to 15 per person plus 95. Now it wants to know what's the cost of 77 people. Plug in that 77. You can use the calculator to do the math. 15 times 77. I can't see my keyboard. Let me go times 77 and then plus 95. All right, so it's $1,250. Hopefully we have time to do a couple more here real quick. All right, so Anna's ordering t-shirts for a community run. The company is ordering from charges $12 per shirt and a shipping fee of $8. Okay, so think about that, $12 per shirt. They're using M for the shirt, so that's 12M, and then a shipping fee is plus 8. T is the total cost, so we need to look at our answer. So this one says 12M minus the 8. You need to add that 8. That's not it. 8 is a separate fee, not the cost of each shirt. This one is the correct one. All right, one more quick question or problem. What is the equation of this line? Start here. It crosses at -2. We can cross off A and B, or A and D. And now let's look at our slope. I'm just going to use my pointer and count up because of time. It goes up 1, 2, 3, 4, and over 2. So up, rise over run. It goes up 4 over 2, and that simplifies to 2. So it'd be C for the correct answer. All right, assignments for the week are here. This was the 4.10. You do have a quiz, so make sure you understand everything before you take that quiz. Reach out to me if you have any questions, need help.